Hello, this is our research paper one presentation. We are investigating L2 normal based PCA for image recognition paper. So we are group 9. What is the PCA? The PCA is most data analyze most to for making predictive model. It's commonly used for dimension reduction. It can transfer the higher dimension. You can see this one is 2-dimension data into 1 dimension, and transfer more like a 5 or 4 dimension data into like a 1 dimension or 2 dimension. So it's a dimension reduction most.
Okay, so these are the related works of PCA. These are the what the author proposes, which has a closed form solution, has good reconstruction error in their error function. They have rotational invariance covered. They are not prone to outliers. They have their solution as an eigenvector, and they sort of solve their computation error, which was not solved in all of them. And yeah, I'll try to explain each of these in more detail. So reconstruction error is an error that, as the name mentions, when you try to reconstruct your data. So this is a high dimensional data of a human picture, and this is a low dimension data of human picture. So reconstruction is when you try to make a reconstruct your data from low dimensional data into high dimensional data. So if you want to reconstruct a face image from this image to this image, you will be able to make a like sort of similar face image from here to here. If the result from here to here differs a lot, you have a lot of reconstruction error. If you reconstruct the face from here and you reconstruct almost the same image, then you have a very low reconstruction error. Outlier problem is so every model, machine learning model, any model should not be prone to outliers. And as you can see here, if there's an outlier in the PCA model, the model result changes dramatically. So this paper wanted to solve the outlier problem as well.
Okay, we mm, the paper focus on the difference between L1 and normal PC and L2 normal PC. For L1 normal, it's just the addition of absolutely value, but for L2 normal, it's the distance between different point. So, but the L2 normal can have a parameter called P. So the author change P to find the best L2 normal PC. Then
Yeah, so to be more specific, the original PCA uses Euclidean squared distance, and L1 norm uses this distance, which is just a L1 norm. And this paper uses a L2 norm mostly, but uses LP norm, which is a P squared here in some of the error function, and usually L2 norm in most of their error functions.
okay. Uh, so then they build a model and calculate the reconstruction error. They build the nearest neighbor classifier, which is which can return the class for each data point. So and they use this formula to calculate the reconstruction error and make the table and graph to compare their result. So they use the comparative experiment. They choose 3 face data set: AR, extended yellow B, and CMU PIE. So it's consists of different face with over 100 person, with over 100 people, and they build a model on 3 data sets. Then we can see the result. The finding of experiment in reconstruction error, the L2 PCA with P equal to 0.5 get the lowest reconstruction error, and the L1 PCA get higher reconstruction error than any of L2 normal PCA. And for accuracy,
Yes,
for
so,
accuracy,
yeah, Kangdong, you can.
what? And for accuracy, the PC, we can see the L2 normal PCA with 0.5, P equal to 0.5 gets the most highest accuracy. It's around 60, but for L1 normal PCA, they get 56 or 55 in both in first table, in first dataset. But in second dataset, the L2 normal PCA also get the highest accuracy, and we can say the L1 normal PCA cannot have the the best accuracy in all the PCA modes.
Okay, and the outlier problem has been solved from this model that the author gave. And so the blue line is what this paper is proposing. And as you can see, even with the outlier, there's no difference with the PCA model without outlier, which is like huge improvement on like outlier problem.
Okay.
So the conclusion is that their model is much better than the original PCA model, PCA L1 model, and like any other PCA model combined. They may have this P parameter which they have to solve for each different task, but all the data set they have tested on, they had the best performance out of all PCA model.
Okay. We go to last. Our future work is we can use this PCA L1 and L2 normal PCA applied to our dataset for image classification. Yeah, we definitely will try two different PCA, L1 and L2, to find the best one. Then we can write like use PCA to improve our computation time, to save more time, save more energy, and to accelerate our model building.